Yeah, so if you go to the netminion.net portal and you can go to the trainings and you can go to the networking, then you browse the Cisco data center ACI, you will get this page. So this is cover. This is having the details about the what is we are going to cover in this course actually. So the course content, let me walk through the course content so that you should be well aware in advance that what we are going to discuss in details. So first thing we will start with the Cisco ACI overview, like what is ACI, why we bring ACI, ACI actually comes into picture when we were doing the traditional networking for past 10 to 15 years. So now what is the advantage this ACI bring into picture actually? We'll talk about the various aspect that make ACI a very uh, concurrent solutions that make ACI a very data center solutions for today's scenarios. Then we'll talk about the ACI architecture and the building blocks. Like we'll talk about how we can connect the leaf and spine and the epics. So what are the different hardwares available? How we can actually connect. Okay, we'll touch base on the hardware as well. Then we will build the fabric, like how the epic will discover the fabric. Okay, how exactly it works with the help of LLDP and DSCP, how it whole discover the fabric. Okay, and how you can put the node ID, VTEP pool, and all those things we will discuss there. Then we'll start gradually going into the policy creations. So let's say if you want to connect a server, so how you can create a policy so that you can configure the server to connect and talk to the rest of the network. So from there, ACI access policy will gradually start looking into the policy construct of the ACI. Okay, so let's say interface policy group. Let's say you want to create a CDP, LLDP enable 10 gig policy, LACP active, LACP passive, all those things will start looking into that, like domain, VLAN pool creation. Then ACI logical constructs will start looking into this, like tenant, BD, VRF, EPG, VGNE, preferred group, and all those things we will see. ACI packet flow. Before the policy creation, I will discuss on the packet flow, because packet flow it's better to understand first, and then we will start looking to the configuration. So packet flow, I will talk how endpoint to endpoint communication happen in the ACI, and also when the endpoint is outside the fabric, how the endpoint will communicate to the inside endpoint. We'll talk about the silent host feature. We'll talk about the flood options and the unicast options. What are the various options? What is the layer 2 BD? What is the layer 3 BD? We'll talk about the all the layer 2 connectivity. Like let's say your gateway is outside the fabric, but the server are connected in the ACI and the vice versa. How we can establish that connection? And then once your whole data center is built, how you can migrate the existing network to your legacy network. I mean, how you can migrate the component network component which is there in your, let's say 7K, 5K, 2K to your ACI. Okay, how you can connect firewall, load balancer, all those things we will discuss. We will talk about the vCenter integrations. We will talk about the private network, bridge domain, ACI, and we will also do the lab. Then external connectivity. So if you have any external connectivity, any external routed network, let's say your MPLS, any router on which their MPLS connectivity is there. So how you can connect or extend the ACI connectivity to that router so that all the routing can happen and traffic can flow. All the L2 out connectivity, static routings, and transit routing. Let's say if you have a two L3 out, how the two endpoints which are behind this L3 out can talk to each other. What are the various options? How we can control and take these. Then we will also talk about the management configuration like SNMP, syslog, TACAS, how we can upgrade the EPIC and the leaf switches. Okay, and we'll talk about the, let's say we create a BD, then how we can enable the layer DSCP relay and various best practices that need to be done during the production environment. Monitoring log and fault management, of course. So this is a very high level. I have give you a walkthrough on the contents. So I hope this is okay with you all, guys.
Yeah, that's fine.
Yeah, so this is basically, this is the practice standard practice. I mean, you go to any institute, they are in this module, they will talk on these points only. But since I am not a trainer, I am a, I am a guy working like you only. So I will include my experience while teaching you a concept. Okay, so let's say if I am teaching you about how you can statically map EPG to the ports, and if that is not being deployed on the ports, what are the things you should check? So basically I will bring my production experience and include in every content, or you can say in every topic, so that you can come to know that okay, these things happen in the production environment, and this is how you can fix data, how you will look into the faults. So let's say if you create a construct and you go to the fault and you see that there is some fault is there, how you can read that fault and derive the meaning of that fault, and then ultimately fix that issue. So those, all those things I will tell you, okay, so that it will be useful for you when you are, or you can leverage these concepts in your day-to-day production environment if you are working somewhere or going to work on a project having leaf and spine fabric working in ACI mode. Okay, so this was pretty much about the ACI course content. So for today and tomorrow, I will go a bit slow. Maybe today we will cover around 1.5 hours or 2 hours maximum. Tomorrow also we will cover like less. So initially we will start gradually. Once you mature, getting mature into the content of the ACI, then we will expand our horizon. I mean, maybe 3 hours or 4 hours. Let's say if you sit around 8 p.m. IST, then around 11 p.m. or 11 at 11:30 at least. This is my target. So maybe 3 hours we will go onward, but we will start gradually. Since ACI is a complex, so where there we need break, we will stop there, and where we will feel smooth, we will expand the our time slot. So this is the pace I am thinking to put through the entire class. And about the lab, the main lab which I really feel important, and or it's really important that you have to do, while I am here, when I mean while we are online, and the rest of the lab you can do as per your feasibility. So there is no such thing like that. You have to do all the labs online, or all the labs offline. But the main labs, let's say the fabric discovery, let's say the L3 out connectivity, let's say the access policy creations, vCenter integrations, the main labs you have to do online parallelly. First I will teach you the concept, I will show you how to create that, and once you got that concept, you will make it concrete by doing itself. And if you have a query, you can ask straight away, I will resolve your query there and there itself. Other labs, small labs, some policy creation, standard configuration, all those things you can do as per your feasibility. So this is, you already know, this is a weekend to weekend batch, so you will get plenty of time to do all the labs. So this was about the lab. Okay, so okay, let me start with the fundamental, with the first module, what is ACI. So ACI is acronym, stand for application centric infrastructure basically. So application has a 3 tier: web, app, and DB. So basically, when initially what happened, when application team approached to you and they say web is not able to talk to the DB, then you as a network guy, what you used to say, can you provide me the IP address, the source IP address, the destination IP address? Okay, this is the first thing a network guy used to ask. Can you tell me what is the source IP and what is the destination IP? Because you don't understand what is the app web server and what is the DB server. For them, they talk in that language and we talk in IP, VLAN, port language. So we generally used to please specify the source IP and destination IP, and then we started troubleshooting, maybe trace route, ping and routing and all those things, any ACL or firewall rules we check, and then we fix the issue ultimately. So while the two team talk in different languages, it was very difficult to implement a single task. Ultimately network is built for application run on the top of the network. So ultimately for any customer, it is the network that it is the application that brings the revenue, right? So any application that customer run, it brings the revenue. Your network not bring the revenue. So basically your network should be in such a way so that it can facilitate the application deployment and it can bring benefit to the customer. So ACI basically, here we create a policy based on the intent actually, and when we deploy, when we click submit on the Epic, when we create a configuration and click submit, that policy gets programmed into the hardware actually. So it is intent based networking, so it facilitates the application deployment. We will look further when we'll talk about the various contexts. We will see it's become easy in the ACI to configure the policy and roll out the application very fast. But let's first understand the why we bring ACI when we were doing very well with the this guy, traditional one. So if we talk about the traditional networking, it is a 3-layer. Okay, core, distribution, and access. Second thing, box to box configuration. Third thing, no security isolation. Fourth thing, no policy support. Can you keep on mute? STP issue. No underlay versus overlay concept. No REST API integration or automation. Not that fast as compared to ACI. So these are the major thing. Okay, so let's talk about. So in the traditional networking, you have a 3-layer: core, distribution, and access. Core is a high-speed component. Okay, your WAN, your internet will be connected there. Okay, all the routing happening there, and high-speed connectivity is there, maybe 1 gig or 10 gig. Distribution is there. If distribution is there, so in the distribution layer you create a SVI and your load balancer, all your services component like your load balancer, wireless firewall connect at the distribution layer, and then you create a ACL and route map and all those things at the distribution layer. That means your policy creation. Okay, access is your where your end device are connected, like your access point, your laptop, those servers, all those devices connected the access layer. So at every layer you have to do some configuration, and then for if you have to troubleshoot anything, then you have to start from the access to the core layer. So it is bit complex as compared to the traditional networking. In the ACI we have only 2 layers. One is a spine and second is leaf layer. So core, distribution, access, first you connect the core to the distribution, distribution will connect to the access. Here simple, just 2 layers, spine layer and leaf layer. Okay. Second advantage is, let's say you have to roll out a VLAN. in your production network. So maybe you have enabled the VTP. So what you will do if you have done the server transparent and client mode in the VTP, then maybe you configure a VLAN and it will get replicated. But let's say you have not created the VTP, or let's say some other configuration you need. Let's say you want to run the SNMP configurations. Then what you will do? Box to box configuration you have to do. You have to log into the each core layer, is distribution layer, spine layer. Maybe 50 access switches are there. So in 50 access switches, you have to log in and you have to configure the SNMP. Okay, but here in the ACI, you define a policy, you log into the Epic application policy infrastructure controller, and you define SNMP, and just you click on the submit. That SNMP configuration will be programmed in the underlying leaf and spine fabric actually. So instead of logging to the, let's say in my environment, in one of the data center, I am having 26 leaf switches and 2 spine switches. And in another data center, I have 40 leaf switches and 2 spine switches. So for this much environment, let's assume how much hectic it will be for me. So traditional networking is a box-to-box configuration. Here, there is a single console. There is a central policy manager, which we call it as a application policy infrastructure controller, which is responsible for all the management configuration, all the policy configuration. So here in the, I will say it's Epic, single, no box to box.
Hey, Izhar here. Sorry to interrupt you.
Yeah. Who is this?
Izhar here.
Yeah, Izhar. Yeah, please go ahead.
Yeah, if you're saying that we have only 2 layers, right? Spine and leaf. So if you say spine, so spine is going to take the roles of distribution and core both, or how it works?
See, if you compare with the, exactly compare with the core, it will be unfair actually. So spine, you can say it is a brain, and leaf, all your connectivity will happen at the leaf layer. All your policy happen at the, appear at the leaf layer. But there are certain brain functions which spine do. So not exactly, but yes, if you want to compare, you can say if there is a traditional networking, there is a collapse core and access model. Sorry, core and collapse access and distribution model. That means there's a 2-tier only, core and access. So you can compare, yes, okay, spine is acting like a core and access is acting like a leaf. But it would be unfair to exactly compare like that. But for your understanding, you can say like that actually.
No, but in the traditional, actually the traffic flow will be, sorry for interrupting, but
no, so yeah,
but in the traditional, the traffic will be from the north to south, but here in the spine and the leaf, it will be from the east to west, where the, all the policy, traffic flow, everything will be from the east to west instead of the north to south.
No. Okay, that is okay. I'm coming to that point. I have started just only, but he's asking like, is it okay to compare that thing? That's why I'm saying. Okay.
Okay, fine. Then
yeah.
No, that is not. Okay.
Yeah. So respect to his answer, I'm saying like that. Okay.
Yeah. Okay, I got it.
Yeah. Now, third point is no security isolation. Okay. So let's say you have a core, and then you have a distribution layer, and then you have a access layer. So here in the same set of leaf and spine, you can create a multiple tenant. Okay, so let's say you have a prod environment, you have a development, you have a UAT. Prod, development, and UAT, you can put in a 3 different tenant. So there will be complete isolation with respect to the logical construct and with respect to the your routing and forwarding, because each tenant correspond to 1 VRF at least. So at least 1 VRF you have to create in 1 tenant, right? So your routing and forwarding will be also separate, and total separate container. If you want, you can compare with the VDC actually. So your tenant, you can create tenant on the same set of hardware actually. So complete security isolations. And second thing is the ACI is a whitelist model, and your traditional networking is a blacklist model. So let's say you wanted to go to a club, okay? So, and that in that club, entry is based on the invitation. So if you have the invitation, or if your name is on the list, more specifically, if your name is on the list, then only you will be allowed. So that is known as a whitelist model, because if your name is not on the list, you will be not be able to not able to communicate, you will not able to allow in that club. So that is the ACI. But in traditional networking, what happened? Everyone is allowed until and unless you blacklist that, until and unless you create some configuration and do deny statement. So compared to a traditional, this is very secure, because you are at one time you are logically creating segregation, and also you have this whitelist model where you have to first allow, then only the communication will happen. So it's very secure. Now policy support. So what happened? Or even I would say more specifically, the more better word is, it's a object model. It's a ACI is a object model. 1 minute, guys. So what happened in ACI, when you create an object is nothing but a configuration. So let's say if I create a policy, let's say I create a object, LLDP is enabled. However, LLDP is by default enabled, but let's say I want custom LLDP. I said trans is okay, trans is enabled, receive it disabled, something like that. I customize LLDP policy I create. Okay, that policy, that configuration, I can, whenever and until how many times I want, I can use that. So once you create that object is reusable. So here is, I should say, or maybe I should remove this line, and here I should say each time I have to create. The flexibility only you have here is you can, interface range command you can do, but you cannot select 2 switches at a time. But in ACI, you can select range of switches and range of the interfaces. So each time you have to create the policy, but ACI is object model. You can create an objects are connected to each other and they are reusable. Now, 5th point, HTTP issue. So, in traditional networking, you have this HTTP issue. If you have a redundant layer 2 links, one link will be forwarding and one link will be in the blocking. So that means 50% of the bandwidth is getting wasted, because that 50% of the bandwidth is just waiting for his time to serve. So let's assume you have a 10 gig connection or 1 gig connection. You know that 10 gig and 1 gig ports are expensive. So you have just connected for the bad days, but for meantime they are not working. But in ACI, the leaf and spine work like a routed fabric, so there is no problem of the HTTP issue. And on the top of that, there is a MCP protocol, miscabling protocol. So if you connect by mistake to spine or leaf to leaf, it will block that communication. It will make the port error disable. So there is no chance of layer 2 loop. Now, in traditional networking, there is no concept of underlay and overlay, right? Here you have this underlay and overlay thing. So since there is underlay and overlay, that's why you are able to create the tenant and all the policy. So policy are abstracted from the hardware, and it is like a roaming. So what I mean to say here is, let's say this is my 2 leaf, okay, and here is my server. Server was first initially connected to this guy. Server was connected to this guy. What I have done in ACI, I configure one VLAN, let's say 6. Okay. As soon as I will configure the VLAN 6, that VLAN 6 gateway will be available on all the leaf. That is known as a pervasive gateway or any cache gateway. So after some point of time, if I move this server to here, I don't have to change my server configuration because that gateway is available anywhere. So that means I can do vMotion without worrying about the IP address information, subnet information, or anything like that. My gateway is available at all the leaf. Okay, so now in the same thing, let me discuss one more thing. What happened in the traditional networking? If this is your, let's say I have only access on the core, no distribution layer. This interlink between these guys. Okay, this is my traditional design. This is my traditional design, and this is my A1 access switch. This is A2. This is C1 core 1, and this is core 2. Okay, and if I connect one server here, A1 there is one server, A2 there is one server. Okay, if these two servers are in two different subnet, okay, then my traffic need to be go all the way to the C1. Okay, maybe color I have taken wrong. Then this guy have to go all the way to the C1. There routing lookup will happen, and then packet will go to the access layer A2 and then send it to the my server S2. So you know what happened if any you miss to allow layer 2 VLAN on these trunks, then this communication will not happen. Okay, that is the one challenge. Second is just for the access layer communication, I have to go to the SVI and then come back again at the access layer actually. So this is not very good for the east-west traffic actually. So what happened? Even if you include the distribution switches, so you can assume that it will go to the access layer, then go to the distribution layer, and if your SVI are the core layer, then it will go to the core layer, then come again and then send it to the server. So you talk about the VMware environment where there is a one host, and in the same host you have different VM, you know, different VM. And just let me write down VM1. Let's say this is VM2. Okay, and this VM2 is talking in a VLAN 2 and VM1 is talking in a VLAN 3. So if they want to communicate, they have all the way go to the gateway and come back to the host basically. So for this is not efficient actually. So they are in the same host, but they are two different VM and they are talking in a different VLAN. So for inter-VLAN routing, it should go to the gateway. So this is not very efficient. So since the application is web app and DB, where web talks to the app layer, app talks to the database layer. So you can see east to west traffic is more than the north-south traffic, where let's say from the internet, somebody want to access the web server, or there is some server who talks to the some outside vendor server. That means that server initiate a connections. Okay, so those kind of traffics are north-south traffic. Otherwise, mostly for the T tier of the application, mostly the communication will happen like, let's say this is a web server and this is a deep database server. So you can see from the web will try to talk to the database. So this is more east to west traffic. So making the gateway at the core layer is not that efficient. And the gateway was tied to the physical interface or the hardware. So if you make the router as a gateway, that means when you configure the IP address on the, let's say, interface gig 0 by 0 IP address 10.1.2.1/24, so that means that gateway property is tied to the hardware. It was hairpinned there, but now here there is an underlay and overlay concept. So gateway function is abstracted from the hardware, and it is no more hairpin to the hardware, but it is available everywhere. So here in the leaf switches, if you move the VM, okay, here or here, no matter, because the gateway is available everywhere. So that functionality is not being supported by the traditional networking, because there the gateway is hairpinned actually. But this ACI has this pervasive gateway or anycast gateway that is very useful for the application deployment or east-west traffic. Now you know that in the Epic you can integrate with the REST API, and you can create the configuration like your BD, all the network constructs policy creation you can create with the REST API integration, which is not possible in the traditional networking. Okay, second thing is, I'm going to remove this guy.
So Manish,
yeah, please go ahead.
I'm really sorry for interrupting.
So
no. The one who joined from iPhone, I would request you to please reply for the message of Joya or Parth, okay? Because we need to have details. Please kindly cooperate. You continue, please.
Thanks, Adi. Yeah, okay. So here you can see, if we talk about the standard spine leaf connectivity, okay. Okay, so this is a spine one, let's say. Spine 2. This is leaf 1. This is leaf 2. Okay, and here my apex are there, so they are basically cluster. So let's say they are connected like this. I'm not drawing connection for all, just to save the time, and we will discuss in this more detail how we connect actually. But as of now, you understand that you have a 2 spine and 2 leaf, and there's a cluster of 3 apex which are connected at the leaf layer. Okay, so this is classical spine leaf connectivity. The spine layer switches are 9500 series switches having ASC, application, spine, engine. The leaf layer are 9300 series switches. They are having ALE, application, leaf, engine. Okay, these all are modular switches. So these all are spine and leaf layer. These are modular switches. That means they are having many slots. Okay, they are having slots for the SOAP engines, and they are having slots for the card types, like what type of connectivity you want. Okay, this connectivity from the leaf to spine is supported by 40 Gbps or 100 Gbps. So you can see how much bandwidth we are giving between the leaf and the spine. While leaf can support all the port connection like 1 Gbps, 10 Gbps, 25, 40 Gbps up to, I mean from the leaf to the server side or access side. So if I say from the southbound ports, if I can say, ACI use the terminology, I mean Cisco use the terminology southbound ports and northbound ports. So these are, they call it as a northbound ports, and these are the southbound ports, which are facing the server or end connections actually. So this is supporting measure of the port speed. Even for the FEX connection, if you want to migrate FEX to the ACI, so 100 Mbps also supported, but you have to purchase a different type of leaf actually, which is supporting 100 Mbps as well. So, but these connections, these are very high speed, these are 40 Gbps or 100 Gbps connectivity. Now, in ACI, you can connect all the leaf to all spine, all the spine to all leaf, but no connection is being allowed between the spine to spine and leaf to leaf. So this is very fundamental, you should remember, because people gets confused with this. Our discussion was happening with one of the guy who I was interviewing before 2-3 days. He was saying that if you have to connect a server to the spine in the VPC, the spine needs the interconnections. So no connection is allowed between two spine and two leaf. That means between the two spine and two leaf, spine to leaf and leaf to spine is fine. That is required, but this is not allowed. Fine, everyone?
Okay. So I have one question, Izhar here.
Yeah, Izhar.
Yeah, in VPC, we create one keep alive message, right? Keep alive
That's
link
right.
is there.
Hmm.
So for here, how we are going to use like that for keep alive? So it will go to leaf, then once again go to spine like that, or Epic will manage all those things?
No, the fabric itself acts as a peer link and peer keep alive link actually. So that means yes, this will let leaf from the leaf spine and to the leaf actually. So and then go to the spine. So basically the fabric itself acts as a keep alive link and the peer link. So all the heartbeat will be like here, from here to here, go to the spine. So both spine will come to know about each other that they are alive actually, or leaf will come to know about that they are alive based on the. So let's say if you connect a server here and you connect here and here like this VPC, so the packet will be, the heartbeat will be like this. So leaf 1 will, leaf 2 will come to know about each other that they are alive. Fine.
Okay.
Yeah. So fabric itself act in high level. You understand that. We will understand this more in detail when we talk about the VPC. But as of now, at the high level, you understand that the fabric itself acts as a peer link and peer keep alive link. You are not required to connect to the two spine and two leaf. Okay. If you connect that, so by default, MCP works in the behind the screen MCP, which is known as a miscabling configuration protocol. It will error disable the port. If you by mistake, let's say you are a data center engineer and you went to a data center, and by mistake if you connect these to spine, MCP will block the one port actually. It put in the error disable state actually, because that for then is, if you connect that and MCP will not work, then a loop can occur. So that's why MCP works on the top of the fabric.
Okay.
Yeah.
So Manish, it should be required MCP enabled in the Epic, or we can work without the MCP?
See, the best practices say MCP you should enable. Okay, and even if you go to the global configurations, there is an option, or per VLAN configuration is also there. So the best practice say you should enable the miscabling configuration protocol per VLAN actually.
Per
So
VLAN.
yeah, per VLAN actually. That is the best practice. So globally it should enable, but as well as, so it's like you have enabled the CDP, but also at the interface level, CDP needs to be enabled, right? The same thing. So you go to the fabric, and the fabric level, you enable the MCP, and then also enable the per VLAN. So here per VLAN means per VD configuration actually, but here I'm not introducing this term because you may be familiar with the NCI, but there are few audience who is not familiar with the ACI. So still I am taking the traditional terminology. Later on we will gradually when we'll look into all the terminology of the ACI, then we'll talk there. Okay. So as of now
I
we
think
are
you might
talking the
mention the
fundamental.
MCP was not enabled, so I asked.
No, that is okay, but keep this question as of now. So first focus on the fundamental, and then we will gradually see what is there and what we should do or not. That is already we will discuss in the industry best practices.
Okay.
Okay, and how it works we will also see. Okay, so do not worry about that. Okay, so just 1 minute. Fine. Now talk about this guy. Now let's talk a bit about the. So we have covered all the differences between these tools, right? We talk about the layers like traditional core distribution access, here spine and leaf. Okay, we talk about the segregation and security policy. Here we can create a tenant, we can create a contract. Only without contract the communication will not happen. That means this is a whitelist model. Third one is gateway is available at all the leaf, that is the pervasive gateway. Fourth one we talk about this overlay and underlay concept and other things we concept. Okay, now let's let's talk about the class architecture, which is this guy. So this thing, this architecture where you connect the leaf to spine and spine to leaf, this is also known as a class architecture or spine leaf architecture. So anybody can ask you like your data center is a class architecture, or they can say like a spine leaf architecture, or this is a traditional networking. So I hope now you understand that this is the spine leaf architecture, and this is also known as a class architecture because this architecture has been derived from the telecom industry, and there was a scientist known as Claus who invented this connectivity basically. So what is the advantage in connecting this way? Let's see. So here, let's say there is one server which is here, and there is one server which is here. Okay, and you connect the leaf one, let's say the single connectivity, just single interface connectivity, and this is S1, and this is the S2. Fine. Now S1 is connected to leaf 1, S2 is connected to the leaf 2. So let's say S1 wants to talk to the S2. Okay, so when the packet will arrive on the leaf, so whether leaf select this path or it select this path, okay, the destination is always one hop away. Technically it is 2 hop away, but in documentation they say like 1, maybe marketing terminology. So let's say the packet will go to the spine 1, and second hop will be the leaf. After that the destination S2 is connected. So you can see whether, so some hashing algorithm happened behind the screen. Actually, you cannot override that. So maybe that this time leaf can, because that is a per flow load balancing in the fabric. So for one flow, it can take this path from the spine 1 to the leaf 2 and go to the destination. For another flow, it can go to the spine 2 and leaf 2.
You lost nothing. You never did love me. You put everyone above me. You made me feel like I wasn't shit and you don't discuss me. See, when I lost you, I lost my greatest something. But guess when you lost me, it's like you lost
Guys,
nothing.
if you are not
You never did love
Radhe,
me. You put
can you keep on
everyone
mute?
made me feel like I wasn't shit and you don't discuss me. See, when I lost you, I lost my greatest
Can you
something.
put on mute Netminian host? Who is that? Can you put Radhe on mute?
You never did love me. You put everyone above me. You made me feel like I wasn't shit and you don't discuss me. See, when I lost you, I lost my greatest something. But guess when you lost me, it's like you lost nothing. You never did love me. You put everyone above me. You made me feel like I wasn't shit and you don't discuss me.
Joya, you there?
When I lost you, I lost my greatest something. But guess when you
Hey,
lost
what
me,
is this happening?
you lost nothing. You never did love me. You put everyone above me. You made me feel like I wasn't shit and you don't discuss me. See, when I lost you,
Radhe,
I guess when you lost me, it's like
oh my God. Okay, guys. So, where I was. Okay, so I was saying that in ACI, it is a per flow load balancing. Okay, so let's say if this leaf server 1 S1 want to talk to the S2, so for one flow it will take this path from the spine 1 to the leaf 2 and go to the S2. For another flow it can take this path from the spine to the leaf 2 to the S2. So no matter what path it will take, the destination is always one hop away. So you can, these bandwidths are equal. So if you deploy all are as 100 or 40 Gbps, so you can see it is equal bandwidth and equal path. So that's why it is known as a equal cost ECMP, equal cost ECMP, equal cost multipath. Okay, equal cost multipath, because no matter which path it will take, the destination is always as one half away with the same bandwidth, basically. So this is one of the biggest advantage you get in the with the class architecture. Now, so guys, you are okay with this pace, right? I'm not going too fast or not too slow. Pace is okay, right?
Right.
Yeah. It's very good.
Yeah. Thanks for confirming. Okay, so or maybe I should use this diagram. Now here there are epics. Now since I talked bit on the hardware as well of these spines and the leaf, so what is the epics then? So epics are UCS C series servers. They are UCS C series server. So they are hardware appliance. First of all, remember that. Okay. So what happens? These epics are, programmed with the epic software inbuilt. I mean, when the Cisco send it, and then you connect. So there in the epic has a 2 10 gig connections and 2 1 gig connections. So what happened with the 2 10 gig connection? You will connect one as a leaf 1 and another as a leaf 2, obviously for resiliency. And the epic side, it is active standby NIC teaming. So I hope you guys understand the active standby teaming, because NIC teaming, we all know that it is kind of a port channeling at the server side. So this is active and standby NIC teaming at the epic side, epic server side. Now, having said that, this guy will be the active and this guy will be standby. Okay, that means until this connection is okay, this connection is not going to use, because this is active standby NIC teaming at the server side. So when you connect this epic to the leaf 1 and leaf 2 in that way, and you power on Okay. Then Epic give you one wizard. There, you know, it's in the front of the. Okay, let me take a new diagram. It will start like this in the bold. It should be, say, like Epic, and then it will ask you few basic questions like, what is the name of the Epic? What is the Epic ID? What is the name of the fabric? What is the pod ID? What is the VTAP pool? What is the multicast pool? And out of band management address of the Epic, and then admin credential, and then click on the submit, or yes, I mean, you are okay with that configuration. As soon as you do, Epic will take that configuration and boot, and then let me quickly draw again one diagram very fast. And this is my Epic, let's say. Spine 1, spine 2, leaf 1, leaf 2. Okay. So this is my, just on one Epic for simplicity. And this is my topology, and this is my active. So what happens when the Epic get the configuration reboot to instantiate all the configuration during the wizard? It's like a WLC configuration. If you have done the WLC initial configuration, same way. It will ask some, in the black screen, it will ask some details you put there. And then when the Epic boots, it will first discover this guy leaf 1 via LLDP. And then with the help of DSCP and the VTAP pool you define during the wizard, it give one IP address. So let's say if my VTAP pool is, you have configured like 10.1.4 10.1.4, okay, and let's say /24, but /24 I have just taken example. You should ideally take /16, the bigger pool, so that in case, let's say, you are expanding your network, then you don't run out of the VTAP pool IP address. But let's, for my simplicity, I have taken 10.1.4.0 /24. What will happen here? It will give one IP address 10.1.4.1. Then it will discover the spine via LLDP, and then via DSCP it will release 10.1.4.2. Then again it will come to the leaf 2, so it will give like 10.1.4.3, and then leaf 2 is connected to the spine, so it will give IP address like 10.1.4.4. Okay, so here when the Epic boots with the initial configuration having LLDP and DSCP by default enable here, so first it will discover the leaf 1 because it is connected, directly connected, and this link is active. This link is active. So first it will discover the leaf 1. It will give one IP address from this VTAP pool. Then it will discover the spine 1 with the help of LLDP and give again another IP from this VTAP pool. Then it will land on the leaf 2, give one IP address from this VTAP pool, and then go ultimately last to the spine 2 and give one IP address 10.1.4.4.
Manish, I have a question here, Izhar.
Yeah, Izhar.
Do we run, can we run CDP here like you are saying that we are using LLDP?
Yeah.
Can we use CDP as well, or only LLDP will run here?
No, this is UCS C series server, right? So this supports LLDP.
LLDP.
Yeah.
A second question that we have created, suppose here VTEP pool, and we are using DHCP. So the first type is going to leaf 1, then a spine 1, then a leaf 2, then a spine 2, right? So one by one. Suppose if I want to make it that 4.1 as a leaf 1 and 4.2 as a leaf 2. So can we configure manually as well, or IP address?
1 minute. I'm going to come on this point. Just make this point right down.
Sure.
So if you want, you can make note of these points. Here I have written LLDP and DHCP plays a very important role in fabric discovery. So if LLDP and DHCP is not working in your UCS C series server, it is not able to do the discovery. Then what is the VTEP? VTEP is nothing but a VXLAN tunnel endpoint. So the IP address which this guy is assigning from this pool is nothing but a VXLAN tunnel endpoints address, and these are dynamically assigned. You don't have any control on that actually. So for these assignment, this UCS C series server or EPIC acting as a DHCP server. Then node ID, VTEP pools, and infra VLAN. You cannot change once the fabric is built. Until the fabric is totally erased and rebuilt, you cannot change that. So I hope this answer your question, Izhar.
Yeah.
Then when you take the VTEP pool, always take a bigger VTEP pool, let's say /16, because not only the nodes take an IP address, but whenever you create a VPC, it assign one IP address to the VPC as well, because then the two switch acts as a logical switch. There, the tunnel is formed between that logical IPs and this IP address which is on the leaf actually. So I will explain. So that leaf when you create a VPC, let's say this is my server and you create a VPC, then one IP address also get assigned from this VTEP pool, because then in this case, these two leaves act as a logical switch. Okay, so that in that case, for forwarding, one IP address also assigned from the VTEP pool. So that's why, and if you know going forward, you connect more leaf, you know, more spine. If you have some port requirement, then you can connect more leaf, right? So for that's why it is recommended to have at least /16. And when you take the infra VLAN use that VLAN which is not in the which is not being used in the your network. So let's say if you configure a VLAN, let's say 3200 3251. So 3251 should be not used in your network somewhere else. Now, 1 minute.